I'm calling this a Python road test, but I don't really know that that's really what it is. I'm thinking like, okay, you need to use Python, web VPython, not real Python, web VPython in your physics class. And these are the things that you really need to know how to do. So I'm going to go through this worksheet. I'm going to solve all these problems that I wrote myself, and we're going to do it straight through. Let's just get to it. Okay, so number one, let's look at question number one. I hope you can read this. Conditional statements, that's the topic. Start with x equals 0, make a loop to print the value of x with step sizes of 0.2 up to x equals 1. That's pretty easy, but let's just do it. Okay, starting from scratch. Now, going over here, okay, that's my sheet. There are two common ways, and there's a third way that you can do this. Number one is to use trinket.io. So here's trinket.io. If you want to do this, and you go to new, up here, new trinket, make sure you use web VPython. That has all the graphing stuff built in. If you just use Python, it's just Python. Okay, and then down here, you're going to have blocks or Python, do Python. The other option that when we're going to do this, the other option that I'm not going to use, this is glowscript.org. This is the original site, and it's really great. You do need to sign in order to create a program, but once you do that, it looks very similar, but it's not quite the same. I like Trinket because you can split the screen into code and output, but I'm just going to make this really big so that we can see it really nice. There we go. Okay, let's go. X equals 0, dx equals 0.2, while x less than 1, print x equals x plus dx. Now, let's just run this. And you see that we don't get 1, okay? And this is the problem that we come up with because of our lazy loops, and it doesn't usually matter. Imagine that if I have dx is 0.001. I mean, I'm going to get close enough that I don't really care. Now, if you really want to get all the way to 1, then you want to put less than or equal to right there, and then it'll get it. So, or you could do, there's a couple of number of things you could do. You could print it after you update. I mean, it does get to 1. I just didn't print it. I printed it the initial one. So those are things you could think about, but maybe you don't really need to think about them. So it's not that big of a deal. Making a loop, that's important. So in a loop, we're using while here. We're using a conditional statement, colon, everything tab indented as part of that loop. Yes, I'm going fast because there's a bunch of stuff to do, and we got to do it. Okay, pause the video if you need to. Okay, number 2, plot a function. Make a graph of a cosine omega t. Oh, that's weird. Cosine omega t plus pi over 3, where a is 0.5, omega is 4.3, from t equals 1 to 6. Okay, let's see if I can remember that. Okay, I'm going to put my constants here. A equals, well, see, I already forgot. A equals, what was it? A is 0.5, omega is 4.3. A equals 0.5, omega equals 4.3, t equals 0, dt, I don't think I said what to print it. I'll put 0.01. And then I'm going to go from t is, I'm not really good with memorizing. I'll tell you right now, I'm having a problem. T is 1 to 6. Okay, that's fine. We can do 1 to 6. So t is 1. Okay, make a graph. Number 1 step. G1 equals graph. Title equals hello there. You can put wherever you want. This is just for practice. This is not for real graphs. X title equals T. Y title equals F. And then here's, you can put a comma, return. You can wrap around the statement. I'm going to put width equals 400. Height equals 200. So these are all parameters of the built-in object graph. I named it G1, which you don't actually, you could just type graph. The width and the height give me the size and pixels of the graph so that it's not too big. Okay, that's the border and everything. Now I need something to actually graph. I'm going to call that F1, and it's a function G-curve. Again, graph and G-curve are built into web VPython. Oh, I told you the third way to do it. GlowScript, Trinket. You could use real Python, install the VPython module, and then import the VPython module. Okay, that is another way. I like to give my G-curves color.blue, just because it looks cool. But you don't have to. You do whatever you want. Now down here, I'm going to change my loop to T, while t is less than 6. And I want to calculate f. F equals a times cosine omega t. Yeah, omega times t. I'm using w. Plus pi over 3. So pi is a built-in number in VPython. You can just type pi. So now that I have that function, I'm going to plot it, f1.plot tf, and then I'm going to increase one of my value of t. Otherwise, I'll be in an infinite loop. If I don't get in an infinite loop sometime during this tutorial, then I'm doing something wrong, because I always make that mistake. T plus dt. Okay, let's run that. There you go. Hello there. There's your graph. Okay, that's nice. So those are the 3 things you need to remember for a graph, right? Number 1, the axis labels, which if you leave it off, it's fine. Like, I can take this out, and it'll still run. It just doesn't give me any labels or anything about the graph, so I do want that in there. And then I just need to plot it. I need to create my curve and then plot my curve down here. Okay, I think my window's too big, small. Let's make that so I don't accidentally run off the page. Okay, going back to the sheet. We did number 2. See, we're moving right along here. We're making progress. Plot 2 functions. I have 2x squared minus 3x and 3x cubed minus 2x squared. Okay, I'm going to use this as an opportunity to make Python functions. So this first one is 2x squared minus 3x. So going back over here, let's make a function, def f1 xt. F temp equals, what was it, 3x squared minus, no, gosh, I'm not really good at this memory stuff, am I? It was 2x squared minus 3x. 2 times x squared minus 3 times x. Okay, so what I've done here is I've made a function. So you can define a function def. I'm going to give it a name, f1. I'm going to tell what variable I'm going to pass to the function. So in this case, I'm going to call it xt just so I don't confuse that with my other variable x. So I use t for temporary. And then down here, I can use whatever variable I pass, xt, in some calculations. And then I want to return that function ftemp. So if I give it 2, it's going to say xt is 2, 2 squared times 2 minus 3 times 2, and it'll return that number. So it acts just like a mathematical function, which is kind of nice. Okay, let's get rid of this. I'm going to leave that f1 lowercase as the graph. f2 equals g-curve, color equals color.red. You got to tell them apart. And let's give it a label. Label f2. This one, label f1. And then up here, I'm plotting x. I'm going to change that, and I'll leave that as f. Okay. So that's my other function. Now let's make the f2 function, def f2. Again, I'm going to use xt because it's only used in this function, so it's fine. And ftemp2. It doesn't exist anywhere else. And the other function is 3x cubed minus 2x. I just made those up. 3 times x cubed minus 2 times x squared, xt squared. That's right? It doesn't really matter. Yeah, okay. And then return that ftemp. Okay, now I want to make this graph from 0 to 3. So I'm going to say x 3, and then up here I don't have an x value, so I do need an x. So x equals 0, dx equals 0.01. That's fine. Now I'm just going to plot things. And this is something that's really nice. Watch this. Let's just delete all that stuff. And I'm going to say x equals x plus dx before I forget. Now I'm going to plot the function, right? I'm going to say f1.plot. The x value and my y value is going to be f1 of x. See, I can put the function in the function, and I love that, right? Because it makes it super nice. And we can treat that just like a math function. You're plotting x versus f of x. I don't need to calculate the value separately. I can calculate it right there when I plot it. And f2.plot x f2 of x. That's it. Run it. Let's see how many errors I make. How many times I get things that don't run. That ran. Boom. Cranking along here. Okay. Back to the road test. Number 4. Make a loop that prints n equals 1 to 10, the integers. Okay, that's fun. I'm going to comment out my graph because I'm going to have more graphs on here, and I don't want to have to write them. Let's just delete this one. I don't think I'm doing 2 graphs again. And then I'm not saving anything because I don't really care. So let's just delete all that stuff. And you may think, wait, I want that. Well, pause it and go back and look at it. It's fine. I wanted to print out n equals 1 to 10. There's a lot of ways to do this. But one of the things you want to do is to do it the way that makes sense to you. N equals 1, n equals 10, while n less than n, print n equals n plus 1. Now, will that work? You know the problem, right? If I just want to print it, it's not going to work. Because I'm going to get all the way up to 9. Because think about what you're doing right here, right? Once I'm going to print 9, and then I'm going to add 1 to that, and it's going to be 10. And up here, no, it's no longer in that loop, so I end the loop. If I do this equal to, then it will get it. Now I'll go 1 to 10. Okay. There's another way to do it, but I'll show you the version of that in a little bit. This is just the counting thing, right? Sometimes we want to count. It's the same thing as x, but it's just a little bit different. Okay, going back to here, we did that. I did it. Number 5, make a nested loop that prints all the combinations of numbers 1 to 5. That I like. Okay, 1 to 5. So I want to do 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, and so forth. So this is going to be a nested loop. Let's start off like this. I have this, and let's just change this to 5. So, and if I run that, I'm printing off the number 5, 1 to 5. That works. Let's call this N1. Let's call it N2. 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 Here's where you're going to make a mistake. N2. N2. Okay. Now, I want to go through another loop. I'm going to call this N1. N1 equals 1. And I want to loop over that, and every loop change N1. So I always get this backward, and that's fine. So let's go right here and say N1 equals 1, while N1 less than or equal to N. So here I have a nested loop, you see. So I'm going to go, and then I want to increase the value. I want to print N1, N2, and then I'm going to increase my value of N. N1 equals N1 plus 1. And then once I get done with that loop, I'm going to increase my value of N2. I go back up here. I need to reset my value to 1, right? N1 needs to go back to 1. Otherwise, it won't work. Okay, I think this will work, but here's where we're getting in the territory where I might make an infinite loop. Not sure. Run this, and I didn't. Okay, so I want that backwards because I want to look. That's not the way I think about it. It worked. But let's just print N2, N1. That's the way I think about it. There we go. Okay, now I want to show you another way to count and another way to do this whole thing. Am I going too fast? Sorry. You know, there is a slow button too. For I in range 1, 6, print I. Let's watch what happens here. So this prints the numbers 1 through 5, right? So this says take the number I, the variable I, and then let it go through this range of numbers that goes from 1 to 6, and it doesn't print the last one. So it starts at 1, it ends at 6, but it doesn't print the last one. Okay. Now I can do this. For K in range 1, 6. So I have a loop in a loop, and I don't have to worry about incrementing it and stuff, because it will do that automatically. I can just print IK. There you go. Same thing. A little bit nicer. But do it the way that makes sense to you. I mean, that's the most important thing, right? Even if you didn't have a nested loop, you just did copy and paste loops. Do the way that works for you. That's important. Moving along. Make a vector A, 1, 2, 3, vector B, -1, -2, 1. Okay, I can't even remember that. Okay, 1, 2, 3, -2, 1, -3. B equals vector -2, 1, -1. I think that's what it was. It doesn't really matter. Yeah, that's it. And then A is vector 1, 2, 3. They can be anything. So vectors are built into Web VPython, which is super nice. And I can print these. Print, just so you can see what it looks like. A equals A. It's a vector. Okay. Now let's do the following. I'm going to add them, dot product, cross product, 3 times magnitude. Okay, so there's a bunch of stuff. So add them together. Let's just write this. I'm not going to print that. Let's just do everything. Print A plus B. Print the dot product, dot A comma B. That's a built-in function. Print the cross product, cross A comma B. Print 3 times A. That was one of them. And then print the magnitude of the cross product of A, B. And there you go. So it's just practice working with vectors. There's a lot of stuff you can do, but those are the very most basic things. What you can't do is add a vector and a scalar. Don't do that. Don't. It'll give you an error, which is kind of nice. Okay, back over here, moving along. Euler method. Okay, here's the function. This is the function for a real pendulum. And let's find the solution for 0 to 3 seconds, assuming the initial angle is pi over 4. Okay, so I'm not going to go through all the details of the Euler method. Let's just do this. We are going to make a graph. So I'm going to turn that back on. And let's call this pendulum. And then the x title is t, the y title is theta. And that's fine. We're not going to have a label here. And let's just get rid of this stuff. Theta, oops. Theta equals 0. No, theta is pi over 4. Theta dot is 0. T equals 0. dt equals 0.01. G equals 9.8. I don't think I gave it a length. Let's say length is 0.5. Okay. So the key for an Euler method is that we're going to use that equation to calculate the second derivative, use the second derivative to update the first derivative, use the first derivative to update the position. So while t less than 3, calculate theta double dot. So I'm going to call that theta d dot. That's what I like to do, but you call it whatever you want. If you want to call it alpha for the angular acceleration, that's fine. Negative g times sine theta divided by L. That is my differential equation. That's it right there. I'm just going to calculate that every step. Now I'm going to use that to update theta dot. Theta dot equals theta dot plus theta double dot times dt. And again, if I don't have my initial angle right there, if I don't have my initial angular velocity, I can't update it, right? The very first time, I have to have that. So you have to have the initial conditions to do this. And now I can update theta. Theta equals theta plus theta dot times dt. And now I need to update time. But let's plot it first. F1 dot plot t theta t equals t plus dt. I've never saved this. I haven't saved it once. And I got it. Boom. Worked. I do want to point out, though, right? This is a numerical solution. And in a numerical solution, we do not have a function. This looks like a cosine function, but it's not because the angle is too big. But also, it's just data. We have data for the solution. And that's fine, right? It is what it is. We don't have a function for that. We have data. That's just data. Okay. Make an animated graph of the function a cosine omega t from 0 to 5. X is 0 to 5, t is 0 to 3. Okay, so a 0.2, omega 1.1. I can't remember these things. So let's just put this in here. A 0.2, omega is 1.1, t equals 0, x equals 0, dx equals 0.01 dt equals, I'm just writing this down before I forget, 0.01 a cosine x, k is 0.5. 0.5. K equals 0.5. Okay, we could make a function to calculate this function, but I'm not going to do that. Let's just do this. Let's start off like this, because what are we trying to plot here? I want to plot f versus x. So this is going to be x on the x title, and this is going to be stuff. And this is going to be f. So I want to do while x is less than 5. And this is not an animated graph. So I'm going to calculate f. F equals, let's call it f, yeah. A times cosine k times x minus omega times t. That was my thing, right? That was my function. So I'm going to calculate that. Now I'm going to plot it. F1 dot plot x, f. And now I'm going to increase my value of x. X equals x plus dx. Not an animated graph. Okay, that's it. Now, to make an animated graph, what I want to do is to plot that value of x at another time. So I want to increase time and then do that again. So I need to make a nested loop. So this loop of x I need to do for every different time. So I'm actually going to say while t is less than, I'm going to put it at 4 seconds. And I'm going to tab indent this stuff. So now it's part of the loop. Now I'm going to go back. I need to reset x equal to 0, right? Because it's just like that loop before. Every time I get to a new time, I need to go back up and reset x. And then down here, I'm out of the loop, I need to update time. So I'm going to calculate all the x values at different t's. Now, how do I plot that? How do I animate that? Well, to do that, I need a list. I need a list, and which I haven't gotten to list yet, which is fine. We'll talk about it. I should do this out of order. So let's make a list, an empty list. Actually, I'll make it right down here. F1 data equals an empty list. Instead of plotting a point, this plots a single point. I'm going to add that point to my list of data, and then I can plot all the data at one point in time. So down here, I'm going to say F1 data equals F1 data. You can name that whatever you want, plus the data point XF. So I'm going to add that to my list. Now I have my list of data points. Down here, I can plot it. F1 dot data, that's reserved. You want to use that. I want to say, what is that list? F1 data. Now up here, I'm going to say rate 100, right? Because rate 100 says don't do more than 100 calculations per second. Otherwise, Python's going to go as fast as it can, and you won't really get an animation. It'll just do it fast. So the two things, at the beginning of each loop of time, I want to clear my data, and then I want to re-add on my data points, and then plot my data. I think this will work, but I do make a mistake with this quite a bit. So if I make a mistake, you know, it's going to happen at some point. But that point is not today. There's your animated graph. And that looks really nice. Now, you'll notice that as the x values change, it scales that. There's a couple ways to fix that. I'm going to just set the y max and min values over here in my graph. Right up here, I can say y max equals 0.3, y min equals negative 0.3. And that's going to set the boundaries there. You can put them whatever you want. And now it just looks nice. It looks nicer, right? That's pretty. I like that. I like animated graphs. Okay, move on. Moving along. Make a list. 1, 2, 3, 4, 5. Okay, we're doing lists now. Again, deleting all this stuff because just moving on. And let's comment out this stuff. T equals a list. 1, 2, 3, 4, 5. That's it. I can print that. T. So in Python, a list, in VPython, we can make a list with these square brackets. Anything you put in square brackets is a list. You can actually put anything in there. You could put 3D objects in there. You could put vectors. You could put numbers. You can put lists of lists. It's really useful. Okay. So if I run this, I just get 1, 2, 3, same thing. Okay. Now the question over here, print t, print the second item in that list. Over here, I can do that. So here's the first item. It has an index of 0. So if I put print t square bracket 0, that's going to print the first element. And let's print the second one too. Print t1 is the second element, and so forth. I can print the last element. I could do that last element, that's 0, 1, 2, 3, 4, or I could go backwards and say print t negative 1. Negative 1 says start from the other side and be the first one on the end, and that's 5. Go through the list and print all the values of t. Okay, how do you go through the list? This is a pretty good one. There's a couple ways to do this. Let's do both ways. For tt in t. So for tt in t, it says go through the list t and call each element tt, and then print tt. That's it. Here is another way to do that. For I in range length of t, which I didn't print, length, len t gives you the length of t. This will go through I is 0, I is 1, I is 2, and so forth. Now I can print ti, and I'll use the ith index, and I should get the same thing. Boom, same thing. Print the list, change the third item from 3 to 5. That's pretty easy. The third item is going to be T2 is the third item. Let's just say that's equal to T2 plus 1. Add 1 to it. And then let's print T. So I did. Oh, it's from 3 to 5. That's fine. Go through the list except for the first and last and add 1 to the element. This is good. This is useful because this comes up where you, in a lot of calculations, you don't want to change the first or the last number. That's what happens in a boundary value problem. Those are your boundary values. So let's just go back over here, delete that. I want to go through the list, but not go through the first or the second one. For I in range length from 1 to the length of t minus 1. T, I'm going to add 1 to every value. Ti equals Ti plus 1, and then I'm going to print T. So I did not change 1. I did not change the last one, but I added 1 to the other one. So I went through the list and modified the middle stuff, not the endpoints. That is, like I said, it is important. I'm not making stuff up here. Okay. Start with the function 2x squared minus 3x. Make 2 lists. First, a list. Okay, so we're going to plot this by making a list. And I'm not going to do this create a function right here. Okay, so 2x squared minus 3x. 2x squared minus 3x. I'm just going to write it down. Minus 3x. Okay. So we want to make a list. I want to, instead of plotting things, I want to make this function as a list. So let's make 2 lists. X equals an empty list. F equals an empty list. And let's go ahead and add all my values into X from 0 to 1. X, no, I do not want to do that. XT is 0. So I need a temporary X value that I can move along and add things to my X list. So what I'm doing is I'm treating I'm making a data list. That's what I'm doing. And that does turn out to be very useful. I can do my normal thing while X less than 1. Add the X value to XT. No, add the XT value to X. So X equals X plus the item XT. So I can add an element to my list by using square brackets. This is already a list, and by doing this, it adds that number to the end as a list. Okay. Now I need to increase my value of XT. XT equals XT plus DX. So at the end, I'm going to have a list of XTs. And let's just print it. I know it's a bad idea. No, X. I should have a list like that. And it's a bad idea to print that, but I'm going to do it anyway. Oh, first error of the day. Okay. I know what I did wrong. I went pretty far without an error. This is XT. You can't do the list less than 1, right? XT was my counter variable. Oh, another error. Can't find dx. Well, that's funny. Now, if you've used real Python, okay, so it did print it out. If you've used real Python, we don't deal with these lists. We'll use NumPy arrays, and they're very powerful. But we do not have that here, so it's fine. Now I'm going to add my stuff to my f function. So down here, I'm just going to say f is f plus. Now I need to calculate that. 2 times xt squared minus 3 times xt. Remember, xt is my variable. So now I'm going to have an x list and an f list, and they're going to be the same size. It's very important that they're the same size. Now I want to plot them. So let's turn this off. Let's turn that off. I don't need max and min. Turn that off. I do need f1 stuff. That's fine. X versus f. So once I make that, I want to go through the list and plot it. So let's do this. For I in range length of x, you could do length of x or f. And I didn't say 1. If you don't say 1, it's going to start at 0. So this is going to go through all the elements in x. And I'm going to index them with the variable I. Now I can just say f dot plot. Is it no what f1? F1 dot plot. The x value is going to be xi. The y value is going to be fi. So I can plot it. And I don't need to increment anything because it's done that in the for loop. And then I plot that, and there you go. Done. It's a lot of stuff, I know. That's why it's a road test. I mean, did you take a road test when you had to get your license? Yes, it's very stressful. But those are the kind of things you need to know. Yeah, there's a lot more stuff you need to know, but those are the very, very basic. If you can do all that stuff, then you can do a lot of cool stuff in Python. And I didn't cover any of the 3D objects or anything like that. Maybe I'll do that another time. Okay, that's it. Have fun.